Hey guys, welcome to this session. Our topic is the periodic classification. In the past video, we saw the concept of periodic classification, and we discussed the various terminologies related to this periodic classification. So in this video, we're going to discuss about the concept of periodicity. Now, what do we mean when we say periodicity? Periodicity, this is the repetition of similar chemical properties of elements after a certain specific interval in a given arrangement. In the past video, we saw the periodic table. We saw the arrangement of the first 20 elements. Now, this periodicity is simply the repetition of the similar chemical properties of the elements after given a certain specific interval or number in a given arrangement. Now, the given arrangement, we saw the arrangement of those first 20 elements in accordance of their groups and the periods. Now, the repetition in properties is due to the repetition of similar electronic configuration of outermost shares of elements after certain intervals. Now, after certain intervals, there's some kind of repetition of these of the properties of the elements, specifically the electronic configuration of the outermost shares of all these elements. You see that there is some kind of repetition. Now, this kind of repetition is where we get the meaning of this periodicity. Now consider the electronic configuration of the first 20 elements of the periodic table shown in the table below. This is our periodic table of the first 20 elements. Now the electronic configuration of each one of these the first 20 elements, you see that there's some kind of repetition in the same of the same elements in the same groups and the periods. Now from there as well, we get the concept of this periodicity. Now you notice that the elements in the same vertical columns, these are the groups, have the same number of electrons in the outermost shares of their atoms. As you can see, if you try to write the electronic configuration maybe of the first vertical column, they have the same electronic configuration. It means that there is some kind of repetition to the number of the repetitive number of electrons in the outermost shell. Now, from there, you see that because of the outermost, the outer electrons determine the chemical properties of element, then the elements in each period, they tend to resemble each other closely in chemical behavior. Now, from there, since the outermost shell, the one that determines the chemical properties of the element. So it means that these elements in each period, they tend to resemble each other closely in their chemical properties or behavior. Now take an example, the noble gases, helium, neon, and argon. They show a chemical inertness, which is characterized by stable outer electron octet or duplet. Due to this reason, the compounds of the noble gases with the other elements have not been found, since they show the stable outer electron. As you can see, if you write the electronic configuration maybe of the neon, you see that it is stable. If you write the electronic configuration of neon 2, then 8, it means that it is complete. Argon also, if you write it also, it shows complete outermost shell. The same goes to helium. Now from there, we see that they are stable. Now, due to these reasons, that's why the compounds of the noble gases with the other elements cannot be found. Now, the attempts to classify elements by these elements by arranging them in order of their increasing atomic weight shows that the properties of the element were periodic. Now, this means that the elements with the similar or comparable properties appear after a certain specific interval in a given arrangement. Now, this occurrence of successive groups of elements showing strong chemical similarity in this way is what we call the periodicity. So thank you for listening. I hope it's clear. We've shortly discussed the concept of periodicity. Thank you.